Good morning. Thank you for coming. This roundtable focuses on innovation in thermoplastic materials. This topic is closely connected to the previous roundtable on equipment. Why? You have seen there were some questions regarding the material. It's really connected. It's very important that the manufacturers of the thermoplastic materials receive the right inputs and requirements coming from the equipment used in different autoclave manufacturing processes, such as in situ consolidation or stamping. In this roundtable, we have some important manufacturers, material manufacturers, such as Hexel, welcome, Terray, and Syensqo. Thank you, Natalie, Mark, and Johannes, for coming. I would like to thank you for joining and for sharing with us your experience and knowledge about the thermoplastic material. So I'm going to introduce Natalie. So Natalie Smith, she's a business development manager at Hexel, leading producer of carbon fiber reinforcement and resin systems at Hexel. Natalie leads strategic initiatives to support market growth, innovation, and cross-sector collaboration. Mark Bowman is an application development engineer at Terray Advanced Composite, leader in the development and production of advanced thermoplastic and thermosetting materials. Mark previously worked at the Thermoplastic Composite Research Center with 10 years of experience in the field of thermoplastic composite. Thanks. Johannes Treiber is a thermoplastic application engineer manager at Syensqo with 15 years of experience with automation of composite processing in both automotive and aerospace industry. He received his PhD in advanced composite materials from Cranfield University. Thank you. So let's start with the discussion. So I would like to know, Mark, which is your point of view about what are the advantages, the challenges, the difficulties associated with the use of thermoplastic materials in aerospace industry applications in terms of material production and subsequent processing. Please, Mark.
All right. Can you hear me? No? Yes, now you can. Thanks for the invitation. A pleasure being here, also with my fellow colleagues, material suppliers. It was already addressed in the previous sessions that looking at thermoplastics, they're vastly different than thermoset materials, meaning that the processing itself is based on heating, and you melt the polymer, and that allows you to basically reshape it, fusion bond it, whatsoever, and then you cool it down under pressure again. And it was already addressed by Salvador from GKN Fokker that for processing thermoplastics, you need to have a different mindset compared to thermosets. So it requires real specific knowledge in terms of how to process these materials. And the processing aspect is very important for these materials because it can influence to a large effect also the mechanical performance. So this processing needs to be done well. And we know, of course, that looking at the processing, it really depends on what kind of equipment you're using. From the previous session, we've learned there are many different equipment manufacturers for ATL machines, AFP, and that also holds, of course, for all other pieces of equipment, all other processes. So it depends on the specific equipment, but we've also seen that it can very much also depend on the material. So looking at the various materials available from different material suppliers, they may look very similar if you look at the data sheet, but still processing can be slightly different there as well. Meaning that in order to get the optimal performance, you need to tune the processing settings to achieve that performance for all these materials. And that is why, as material supplier, we're also not only supplying the material, but also processing guidelines for our customers, making sure that they do the processing well. We offer technical support. And I think there is, in this case, also an important role for research and application development centers to act kind of like a knowledge hub. They have certain equipment in-house, and they can make sure that we as a community learn, well, the ins and outs in terms of processing materials and their interaction, basically. So.
Thank you very much, Mark. Very neat. Yeah, I fully agree. Yeah, I think the technology centers, they are key in this chain, manufacturing chain process to ensure that all the potential of the materials is developed and is, yeah. From your point of view, Johannes, you have something to add from what Mark has explained?
To add to that one, yeah. First of all, thank you very much for inviting us here. And it's nice to have 3 material suppliers. We will probably get quite a bit of challenges regarding price, but having material and process is a key point. I think from our perspective, from my perspective, we have as material supplier 3 challenges which we really need to address. One is the processability, as Mark said. It's not just the processability, giving the wide enough process window, which itself is a bit of a challenge right now, because I think in the industry it is not yet fully clear what is our need in terms of material boundaries, how many heating steps, how many heat cycles does the material survive. We're going right now very conservative. The same applies, I think, as well from a processability perspective. What are we doing with porosity? How do we address this one? We address this very much with a thermoset mindset still. We have targets which are coming from thermosets. I think that is a point which we can't solve alone as material suppliers. That is a joint work with the industry and with the market players, but also institutes, and here exactly the institutes comes back to it. Besides, on the processability point, we definitely have a requirement from our side when we talk around all these scale up, which I think we're all aiming for and hope for that this business comes. The material suppliers have also to scale up. We will need to do quite significant investment. Classical lines, unidirectional lines have 12-inch. Is this sufficient? Probably not. We need to scale up and then come directly with all the challenges of our thermoplastic polymers, high temperature, viscosity limitations. So we as well face a significant investment challenge, and as such a bit of a clear projection where we're going with quantities, and this needs to be done early enough. Mm-hmm. Besides of this, there's one challenge around processability. I would say two additional points. One is predictability. We said around, okay, we need to have material. It's not just process guidelines. We are trying to provide really material cards, virtual engineering cards. If we scale up that much technology and different technology bricks, how do we get it first time right? Hundreds of tools need to be invested, not just machines. Tools need to be invested. You would say it's the same for thermosets, but here we are on thermoplastics, tooling costs are higher. We're having more investment, which needs to be right the first time. So we're trying to address this one, have application engineering, Mark from the Tory side, we on the Science Go side, have specifically application engineers and teams trying to develop this, not just alone, but with the industry. And perhaps the last point, we had this early on around material and which material is the right one. We need to provide more flexibility. It's not so much just one material. We have a small portfolio right now in polymers, and we mentioned PEC and PEEK, and some of these go back. We have later on David Lead here with very long standing experience, and started off with PEEK in the 90s and before that already. And we definitely still have gaps which we try to close. That means bringing PPS high up, toughness-wise, closing some perception gaps there. But also we had heard earlier on the engine side that the Class A UTG requirements are not necessarily just sufficient, but expanding on that one. So these are 3 challenges which are there, which we try to address, I think, and are important from our perspective.
Yeah, someone said challenges are opportunities as well. So.
Yeah, we try to understand.
Okay, thank you very much, Johannes. Natalie, I would like to know your opinion about what benefits can they bring in terms of material production, subsequent processing, and sustainability.
Yes, thank you, Laura. So as Johannes said, so if you have a small range, we have even a smaller range of thermoplastic. We are very new at Hexcel. We are very new in thermoplastic. We started partnership with Arkema with PKK material in 2018. But on the other side of that, we are providing 52% of the A350 that Susanna was mentioning earlier today. So we're not putting thermoset versus thermoplastic in competition, of course. There will be room, I think, for all of us 3, and there will be room also for thermoset, thermoplastic, and hybridation. In terms of production differences or production easiness for thermoplastic, it's not an easy material to produce. However, we have the expertise from carbon fiber on one side at Hexcel and the expertise of Arkema on the polymer. And so to produce, it's a material that has no storage because no shelf life. So you don't have to store it at -18, so the CO2 footprint will be better. It's also a stiffer material, so it means that the slitting that we do in-house at Hexcel will be easier, and standard deviation of the width is more manageable. Then what else? Then from a subsequent production, of course, we mentioned the avoidance of rivets. The assembly will be much easier thanks to welding.
Expiration date as well, I suppose.
No expiration date. There is no tack from the material, so that's why a lot of you don't need protectors. So no more polyethylene, no more paper. So it's something we sometimes have hard time recycling. So in that case, we won't have to bother about that anymore. And then about sustainability, it's going to be a sustainable material as composites, of course, but maybe more sustainable, more durable, because it has less influence of aggressive fluids. It will be more, it will be stronger with regards to damage tolerance. It will be more repairable and also more recyclable. And we have with our, I mean, it's not our material, but it's a good way of collaborating together. The example of Daher, who was certified PPS carbon recycling for a rudder pedal. It's a flying part, so it means that it's really happening. And of course, it's not the same rules as for Airbus Commercial, but I think it gives a path to, it shows us the way.
Mm-hmm. Thank you very much, Natalie.
You're welcome.
So we have heard in the different roundtables, there are some words that they are appearing all the time, repeating. One of them, it was about the cost. Yeah, because when you have something in development, always the cost is a problem or an issue that is a challenge as well. So this time I would like to know, Natalie, again, what's your point of view about the cost aspect From a broader perspective that goes beyond the material price alone, thermoplastics are expected to help reduce overall costs. As you have said, for example, in the assembly, you don't have fasteners. That's an example. What do you think? What are the key conditions that could enable a reduction in material costs?
Thank you. So I think thermoplastic is a very good example, as in composites, but where we need to consider end-to-end costs, right? Not only the cost of the material, which we know is more expensive than thermoset, but I don't want to put both together. So of course there will be scale price reduction, and there's a chance for us. We came late into the race, but thanks to our innovation, we take benefit from the latest innovation, and we can improve speed of manufacturing and other aspects. But also, I think we need to start. So we need to start, and as for composites, I think it's going to be a step-by-step approach. For A3400, A340, we started with some parts. Then for A350, more parts in composites. For thermoplastic, it's going to be the same. So it's going to be, for example, smaller parts than what we have imagined first for fuselage of the new single aisle. But we need to start at some point. And we need people to tackle the risk, to be brave, and we'll make it happen. We'll be there.
What's your opinion, Johannes, about the reduction of material costs in thermoplastic?
Important is the question around TCO for sure, and one which currently is quite essential to be done in order to identify the right parts, in order to translate also the right material cost to that one. But perhaps on the material side, scale, and as Natalie said, scale is an essential element. We have right now quite small assets still on thermoplastic, so when we scale up, we will expect that significantly, especially on manufacturing, robustness, etc., that will translate quite significantly on the cost. That needs to be covered right now just due to small volumes, etc. The fiber side is another point, but this comes automatically with scale. When we have more fiber demand, then also more flexible on the fiber side right now. We have a very limited, especially for the PAK family, that the fiber selection and fiber range, or the necessity to deal with high temperature sizing is a challenging one that comes significantly with a price tag, and not an easy translation into a 50K fiber, for example, so that we really make we scale from a fiber price perspective as well. That is hopefully with a commitment from more volumes to come, is that we can address this as well. And perhaps the last point is then it's more around the semi-products and semi-finished products as I to set up a really strong supply chain. Yeah. Right now, there's a strong focus on we need tape, or we need some fabrics. But in reality, we need to have also semi-finished products or intermediate steps right now, and later on be set up, and that in order to translate really a total cost price throughout the industry, the supply chain needs to be set up. Needs to be relatively robustly set up. We see this in the US more strongly established already, given the production volumes. But in the European side, we definitely have a need for that one.
Mark, what do you think?
Yeah, so from a material supplier perspective, we see some opportunities to reduce cost by harmonizing certain aspects, so creating more standards, basically. I have two examples that I can share, but there are obviously more. First one, and this is an important one, looking at material certification. We have various different customers, and basically they each have their own requirements when it comes to material certification. And they can differ, for example, in terms of what test standards should be used, or what tests are even relevant to incorporate there, or the test conditions. And as you can imagine, if everybody has different requirements to certify or to qualify a material, That means that the amount of testing for the exact same material is quite extensive to allow it to be used by various different customers, different platforms, etc. So if there is more standardization in that area, that would obviously help reduce the amount of testing. And of course, will reduce the cost associated with material certification and implementing new materials, new thermoplastic applications throughout the industry. And it might not be a very straightforward thing to do. Of course, there are lots of companies that have historical data that they are very familiar with, but I think looking at, for example, NCAMP qualification, that's, I think, a really good step in that direction. And second example that I want to explain, and it's a very practical one. We've seen in the previous session that there are several different equipment manufacturers for example, AFP and ATL. And as a material supplier, we're offering slit tape to our customers, and that can be, for example, 1/4 inch, 1/2 inch, 1 inch, 2 inch. That's all fine. But what we see that within, let's say, one of these categories, so let's pick 1/4 inch as an example, we see many different specifications that our customers require in terms of, for example, slitting tolerances, or how to deal with splices, or also a very practical one, what kind of spools are we using, what kind of bobbins. That can be DIN 250, so plastic spool that you ideally would like to reuse, meaning that you have to ship it back, or it can be a simple cardboard spool. So there are many different requirements, very much depending, of course, on what kind of equipment our customer is using. And if we can, streamline that a bit and creating more of a standard that we can all work with, that would, of course, also help reducing costs.
Yeah, I fully agree. Yeah, because it's true that in FIDAM, for example, that we are with the in situ consolidation. We have these discussions with you.
Yep.
Exactly, that we are requiring some sizes because it depends on the robot, and that is, at the end, is not a standard. Yep. So if because you have discussed, you have talked about qualification, I think it's a really important step. If not, to go forward with the thermoplastic material, we need to proceed with a qualification, and of course that then we can push and escalate all the production of, because I fully agree, Natalie, that at the beginning it was the aircrafts, they were mainly in metal, then little by little they went to the composite thermosetting. Now we have seen that the last aircrafts, they are more with some parts in some areas in thermoplastic. So it's true that we are approaching this scalability, but we need to some help from the government, or I don't know, to push and to help this qualification. Yeah. Okay, so I don't know if there is some questions. Malte.
Thank you. What about vitrimers? So we see the problems with pure thermoplastic materials. We see the easiness and existing activities on the thermoset materials. And depend who you ask, they said vitrimers could be the new future. How do you see it?
Who wants to start? Johannes?
Thank you very much for the question. Yeah, it's definitely part of research. It's part of, but the readiness level is just one of the big challenges. I think for right now, for the target of the next generation single-aisle aircrafts, where thermoplastics is to be positioned very strongly. It's just the readiness level is too low right now, and getting it through the including all the processing behind it, getting it through the organization and through the standardization, it will take time. So it is a good question. We will see. It's still part of research, so we are not yet further, but it's a fair question. Yeah.
And things typically go step by step. So of course, to make use of the full potential of thermoplastics, you want to do stamp forming or AFP combined with welding and combine directly a whole bunch of processing technologies together. But we also see that some technologies have a higher maturity level than others. So it's logical that goes quite gradually because the readiness for each technology is not the same yet.
Natalie, do you have something to add about Vitrimmers?
There has been some work done, I think, by one of our French technical center, IRT, can't remember if it was Jules Verne or Syntex, but who made a Vitrimmer version of RTM6, our resin transfer molding resin system. Results were quite interesting. However, the drawbacks were too high, and I don't think it would need to be followed up by more data generation, more hot wets, more. What about micro cracks? What about so?
Someone else wants to.
Thank you very much. This is Alberto from IMEN Technology Center. Just a question regarding the materials. We see that maybe a limiting factor is related to the cost of the materials or the overall value chain, but maybe one aspect that can be used in order to enhance the potential of these materials is to introduce new functionalities. So, for instance, incorporating graphene, synthetase, carbon nanotubes, etc. That has been in the research for a long time ago, but I don't know, what is your opinion about this putting into the market?
Who's comfortable?
Not too comfortable to answer.
Perhaps picking up on carbon nanotubes, etc. We work already quite, and I think all the material manufacturers work already functionalizing in the sense of using morphology in the thermoplastic materials as a way to adjust materials and behavior of materials. That is the interesting with the thermoplastics. It has a high viscosity, but there means how we can really address that one. At the same time, it comes with the drawback that we are in very high process temperatures, which limits to some extent addition and the flexibility as it is otherwise known from thermosets. So it is a fair question, and it is coming one which comes more and more. I think there was a very strong focus on fundamental main structural materials, but the extended portfolio of auxiliary materials, surface films, welding material, LSP, etc., comes, and I think there the question of additives, of functionalization becomes a key aspect. Although it's interesting that we're still challenging with the industry finding the manufacturing routes, and as such also how these product forms need to look like, and then how we functionalize them. Okay.
I think I can answer, but on a different angle. I think our OEMs are looking for substitutable materials, so it means then you have question of IPs, of everything. PEC is PEC, LMPAEK is LMPAEK, so they want substitutable materials, right? If you start to include graphenes or stuff, I mean, we will need to have all the same product. Do we want to share? I'm not so sure. We'll see.
True. I agree. Okay, so if there are no more questions or someone... another one.
Do you see a growth in the demand for the market for thermoplastics? Well, I'm Ramon Junco from Ernova, and I would like to ask you if you see a growth in the demand for these materials in the future, in the near future.
We see it.
Yeah.
You
We
can
want
measure
it to invest. I mean, it's
Yeah.
sure.
Indeed, so a lot of companies are currently developing new applications based on these materials, and there is a lot of interest that was already there, looking at the benefits of these materials, and that is currently converting into new applications, but also considering aerospace industry is relatively slow. It's also relatively conservative. That takes a bit of time, so it's hard to predict, when that real ramp up is going to happen. But that is what we all expect, not only as material suppliers, but as industry as a whole, I would say. Yeah.
And the whole ecosystem is waiting. Yeah.
Yeah, it's not just the ecosystem waiting. I think we see a joint investment, and that is the important point. It will not be the material supplier's choice, and also not the technology supplier's choice, and the OEM also needs to have a joint effort by the industry. So it's not just do more thermoplastic parts come. No, we see it globally in investment. The technology suppliers are picking up of really establishing technologies which are robust, which are traceable. So it's a joint effort. But yeah, otherwise we wouldn't be here if we would not believe on that one.
Okay, some more questions? Okay, so thank you very much.
Thank you.
There's another person? Johannes?
Yeah, I have a question. Marcus Kames from Airborne. So what about hybrid solutions? It was mentioned before, so thermoset and thermoplastic. Can you comment on that? What's possible and what are you looking into?
Perhaps, should I take this one?
Yeah, go for it.
It is an interface which is deemed important. As such, yes, there's development. There are possibilities. The PAK family is miscible in some form. There are development efforts. At the same time, it is still relatively low in terms of development status. Yeah, the fact that I think from a next generation single aisle application that the outer hull, the fuselage hull, is unlikely to be thermoplastic, but then again, a lot of the repetitive parts are having a good potential for thermoplastics, means we have some interfaces where we definitely not just have thermoplastic to thermoplastic joining, but where thermoplastic to thermoset becomes a topic. And so it is part, but yeah, still development.
Okay, so I thank you, your participation, your knowledge and insights. And yeah, I think that now we all deserve the lunch break.
Thank you all.
Thank you very much.
Thank you.